BCC Hardware here with Jeff Lyon, CEO of CoolIT Systems. Jeff, why don't you start us off by talking about the Vantage?
And it features something very special. The Vantage has built into it actually a wireless communication module. You'll notice there's no wires actually going from the control module here over to the fan, because it's communicating between here to the something that we would call a control module. So the control node up here has an ability not only to govern the fan speed, but also it has expandability so that you can plug in two additional fans if you like. You can plug in RGB lighting. You can see that the lighting actually coming off this is giving us a nice little pulsing glow on the inside of the case. In the past, RGB lighting has only been in the domain of the high-end OEM, right? Like Dell or Alienware or maybe HP, but never in the enthusiast's hands. So what we wanted to do is actually utilize the extensive control and intelligence built into the system and expand it for something fun. Like you can have your own lighting scheme. It can be dynamic the way we're seeing it here. You can actually change color with temperature. You can have it actually blink with alarms. There's a lot more to this than just actually inside lighting.
How is the Vantage superior to the Eco in terms of performance?
The Vantage actually is superior to the Eco for a couple of reasons. The fan that comes standard with the Eco is topped out, as I mentioned, at 1800 and regulated by the motherboard. Since the Vantage has intelligence built into it to regulate with more accuracy and more control, we allow that fan to spin all the way up to 2700.
Okay.
And it's up to the user's distinction as to where they set those limits.
Okay.
You can choose your own band curve if you like to.
Yeah.
The nice thing here is that when you've got the additional speed possible on the fan, we also wanted to give it just a little bit more of an edge. So we have this as a pusher fan instead of a puller, which necessitates having a duct on the back so that you're compatible with different cases.
Okay.
Right? There's actually not two fans on there. It's just one fan
like two fans
and a duct.
Okay.
But the pusher is actually a little bit more efficient, and it pushes a little bit more air with every revolution because it has higher pressure. Higher back pressure to utilize. So the concept that we're promoting is actually zone-based control. So in most software setups or fan controllers, there's a bunch of problems with it, right? You may have something that can control 8 fans, maybe 12 fans. There's some out there, they're pretty beefy, but by the time you actually wire manage your case all the way over to there, you've got a wad of fan wires plus your power and all the regular cables to deal with. It's a massive pain in the ass. So what we wanted to do is actually eliminate the hassle, but still allow all the control. So that's why we've got these little wireless control nodes. And obviously it still needs power, so you just go to wherever you can find yourself a nice, convenient fan header. Or, convert a Molex to a fan header or whatever you want to do. It needs 12 volts. That's all it needs. And then from there, you can plug in 1, 2, 3 fans, temperature sensor, and the RGB lighting.
Okay.
Now, after you've done that, the software recognizes, and it doesn't matter whether you plugged it in here, you plugged it into that one, or a third one, or a fifth one. The software doesn't really care. It just says, hi, I see another fan. Would you like to configure this fan? And it walks you through that wizard to say, okay, I would like this fan controlled in zone 1. Well, actually, when you first start up the software, it says, what would you like to be associated with zone 1? And it's usually based on a temperature sensor. Okay. Right? So you can actually have lights, pumps, fans, at random from anywhere in the case associated with a given temperature. And that temperature could actually be temperature sensor, or it could be an internal temperature, like the CPU temperature. If that's being exposed, through our traditional tools that we developed together with CoreTemp, then you've got a tremendous amount of flexibility. You can say, all right, you know what, I want the fans to jack crazy, because I don't want my CPU to ever go over whatever it may be. And then you can save that profile and say, okay, here's my overclocking profile. here's my media center profile. Here's I'm actually doing work profile. Or here's my wife's profile. So there's, I think, a tremendous amount of flexibility and a new standard that we've set in terms of ease of use.
Oh yeah.
And when you see the setup, it actually gives you a graphical representation. It gives you the status of each fan, what it's doing, what the temperature is in whatever zone you've defined it. You can actually say what location of your chassis it's in. You can choose the background of your chassis or a different chassis. So it really is, I think, a truly useful software interface so that you can manage your thermal setup. And we wanted to provide a forum for people to be educated on how things perform, what they really look like, inside, outside, by themselves, and what I wanted to do to really drive the point home is dispel things like, oh, you know, quarter-inch tubing will never work because it's not half-inch tubing, or the pump is too small, I need to have a giant pump. So there are some subtleties that obviously we're not stupid. We have made these choices consciously. Sometimes it's a trade-off, and sometimes, yes, you may be in a position that you could create a better loop yourself in a DIY type situation. And obviously, you know, with the roots of our company being squarely in that enthusiast space, we've got a ton of respect for the DIY and all the players therein. But what we did want to showcase here was a head-to-head. And so we've got Hardware Labs, Black Ice Rad, Black Ice Rad, and Lang DDC 3.2 going flat out, and one of the high-end Swift-Tech Apogee blocks versus an Eco. Exactly the same fan running. This one's at 54 degrees, this one's at 52. They're actually on the same power supply even to ensure that we have exactly the same power going to each one. Okay, so for the next innovation that we're highlighting here at the show, the Omni Universal VGA liquid cooling system. So the challenge in VGA has always been the fact that, you know, the next generation of video card is always right around the corner, and you've got a liquid loop that you invest a lot of time and money in, and it instantaneously, as soon as that next generation is out, then it's obsolete. You know, obviously we want to maximize performance on the GPU cooling as well, but at the same time we can't ignore the rest of the card. So with the universal plate that we've developed, it has the capability of cooling one GPU or two GPUs as well as the rest of the card. And we do that by having something called an interposer plate. So the interposer plate that we see here, you can see the universal block, then we have custom interposer plates, and see kind of the stages of how that all goes together. You just mount this assembly onto the card itself, making sure that you've obviously got good seating and TIM on the GPU, and then there's actually, it comes with pre-applied TIM on all the necessary spots, so that you're getting the thermal transfer for the VRs especially, as well as obviously the RAM and any other chips like